In this lesson, we will solve literal equations. Literal equations just means that we are solving for a variable, but it's not going to be necessarily a numerical answer. So in this case, I have this equation, I'm trying to solve for y, which really just means to rewrite this so that it's y equals, which means I'm treating this as my variable. I'm saying, how would I get this variable alone? I would first get rid of negative 2x by adding 2x to each side. And just out of habit, I'm writing that 2x first. I could have written 5 plus 2x instead of 2x plus 5, because typically when I isolate y, I'm turning it into slope-intercept form. I tend to write the x first. That gives me y equals 2/3 x plus 5/3. So I did isolate y. I'm done solving. So remember, when I solve a literal equation, it just means get the selected variable alone. For my next example, I'm trying to get x by itself. This one's going to be a little bit more complicated. So when you have more than one term with that variable, we're going to collect those terms onto one side of the equation. So I notice that ax is already on the left side. I'm going to subtract the cx so that that's also on the left side. I only want values that include the x on the left side, so I'm going to add the 3 to the opposite side. So I have ax minus cx equals 10. Now I'm trying to get x by itself. Notice that both of these terms have a common factor of x, so I'm going to factor it out. And I almost have x by itself, but I have this a minus c in the way. So if I divide each side by a minus c, that leaves me with x equals 10 over a minus c. That's my solution. Here's one for you to try on your own. Press pause, do the question, then press play to check your work. Again, I'm solving for y. So I'm going to move the 5x to the opposite side, so the term that includes the y is alone on the left side. Then I will divide everything by 3, which leaves me with y equals negative 5/3 x plus 7/3. So why would we use a literal equation? Sometimes it's nice to go ahead and isolate that variable before we plug in any values. So in this case, we have Chicago's popular landmark of the Buckingham Fountain. And notice that it gives us all sorts of information. 133 jets, 14,000 gallons of water per minute, etc. Circumference is 880 feet. The first thing they ask us to do is simply take the circumference and solve the equation for r. So it's not even using any information here. So I'm going to take this and get r by itself, which means I'm going to have to divide by 2 pi. So on the the right side, I'm just left with r, and on the left side I have c over 2 pi. Notice I wrote those in the opposite order so that I had r isolated first. And now we're going to use all of the information that you give me here, only the stuff that matters, to find to the nearest foot the radius and diameter of the fountain. So r is radius, circumference is given to me as 880, 2, and then pi, they tell me to use 3.14 as an approximation, so pay attention to those. So now I'm just going to use my calculator, of course, to divide 880 by 6.28, and that value is 140.127. Now, they asked me to find this to the nearest foot, so I would say the radius to the nearest foot is 140 feet, and the diameter, which of course we all know is 2 radii, would be double that, which would be 280 feet. Here's a similar question for you to try, so try this question, then press play to check your work. The formula for the surface area of a sphere is given by s equals 4 pi r squared. We're solving the equation first for pi. So I'm going to divide by 4 and also by r squared. 4 and r squared. So pi equals s over 4r squared. In this case, the sphere has a surface area of 113 inches squared, so that's the S, and a radius of 3 inches, so 4 times 3 squared. Now, we already know that pi should end up being about 3.14, but let's go ahead and do the math and see what happens. 3 squared, of course, is 9, and 4 times 9 is 36. So if I divide 113 by 36 to 2 decimal places in my calculator, I get 3.138, etc., which rounds to 3.14. Another application of a literal equation is with geometry. So in this case, we're given the formula for the area of a trapezoid, which of course is A equals 1/2 times the height times the sum of the bases. And they give us a lot of that information here. And in this case, we are trying to find the B1. So we're trying to find the first base. And they give us a bunch of other information. So if you need a visual on this, don't ask me because apparently I can't draw. But we have a height of 8, which means if I have an altitude, that would be 8. The B2 has a length of 16, and we're saying what's this value here if the area is 112 inches squared. So I'm going to first take my equation, and I'm going to isolate B1 because that's what I'm trying to solve for. So to isolate B1, I would multiply each side by 2, which would of course get rid of the 1/2 and make that 2a. I would divide each side by h, which would get rid of the h here and give me the h here. So now I have 2a over h equals b1 plus b2. And I'm trying to isolate b1, so I'm going to subtract b2. So my isolated equation is that b1 is equal to 2a over h minus b2. And now I'm going to use the information that they've given me to find B1. So B1 would be 2 times the area, which is 112, divided by the height, which is 8, minus 16. That gives me 224 over 8 minus 16, which would be, I'm running out of room, 28 minus 16, minus 16, which is 12. So B1 equals 12 inches. Here is one for you to try on your own, so press pause, do this question, then press play to check your work. In this case, we're dealing with the volume of a cylinder, which the formula is pi r squared times height, and we are trying to solve the formula for h. So this one is fairly straightforward. To get h by itself, I would divide by pi r squared, which means to find the height of a cylinder, I would take the volume divided by pi r squared, which is of course the area of a circle. In this case, our volume is 13,552 cubic centimeters, and our radius is 14 centimeters. It does not tell us what to use for pi, so typically I'll either use the pi button or 3.14. Let's just go ahead and use 3.14 in this case. So we would have 13,552 divided by 615.44-ish, and then we are going to divide. And in this case, it doesn't tell us what to round to. What I get for my answer is 22.020, etc. And so I'm going to say that the height is approximately 22 centimeters.